Alright guys, Mr. B here. In this video we're going to be going over the questions in the chapter 26.5 notes. So hopefully this will help clear up any confusion if you weren't sure how to answer some of them. Alright, let's take a look at number 1. True or false, the apparent change in frequency and wavelength of a wave as it moves towards or away from an observer is known as the Doppler effect. That is true. So I know that sounds like a really long, complicated explanation. Basically what it means is if there's a wave and it is moving towards or away from someone who is looking at it, it will seem like the wavelength will be shorter or longer depending on how it's moving. So that's known as the Doppler effect. There's a video on that that you were supposed to watch. Hopefully that will help make it a little bit more clear. How can astronomers use the Doppler effect? So the Doppler effect is used to determine if stars are moving towards Earth or away from Earth, because the wavelength will either be longer or shorter, depending on, again, if it's moving towards us or away from us. So we're going to put that down. The Doppler effect can be used to determine if stars or other objects in space are moving away or towards Earth. All right. Number 3, circle the letter of each sentence that is true about spectrums of stars or galaxies. So, A, as a star moves towards Earth, the lines in its spectrum are shifted towards shorter wavelengths. That is true. So, as things move towards the Earth, the waves that are emitted from that object get bunched up, and so the wavelength, which is the distance between waves, is much shorter, in which case they will be shifted towards the blue side of the spectrum, which is shorter wavelengths. That is true. Letter B, as a star or galaxy circles the Earth, the lines in its spectrum shift towards the middle of the spectrum. That is not true. As they move towards, or as a star or galaxy circles the Earth, well, there are no stars or galaxies that circle the Earth, so I guess we're just going to say that that's not true at all. So, letter C, as a star or galaxy moves away from Earth, the lines in its spectrum are shifted towards longer wavelengths. That is also true. So, if it's moving towards Earth, the wavelength gets bunched up. If it's moving away from Earth, the wavelengths get spread out, and they would be shifted towards longer wavelength or red color. We call this redshift. Lastly, letter D, the greater the observed shift in spectrum, the greater the speed the star or galaxy is moving. That is also true. So the greater the shift in the spectrum, the faster the galaxy is moving away from us or towards us. So that is also true. All right. Number 4, the shift in the light of a galaxy toward the red wavelengths is called a Doppler Redshift. Okay, so shift towards the red wavelengths is called a Doppler Redshift. Number 5, describe Hubble's law. So Edwin Hubble was the one who discovered that most things in space were moving away from Earth, and that most everything had a Doppler Redshift. And he was also the one who realized that as things move away from Earth, they are moving away faster from us because their wavelength shift is getting further and further. So Hubble's law basically says, so we'll say Hubble's law states that most things in space have a Doppler shift, and that as they move further away from Earth, the shift gets larger. So you can say in parentheses, the object is accelerating. Okay, so basically Hubble's law states that most things in space have a Doppler shift, whether it's red shifted, so it's moving away from us, or it's blue shifted, it's moving towards us, and that as they move further away from Earth, the shift gets larger, indicating that the object is speeding up or accelerating. Okay, that's Hubble's law. So. Number 6, astronomers theorize that the universe came into being in an event called the, so this is called the Big Bang. Number 7, circle the letter of each sentence that is true according to the Big Bang Theory. The matter and energy in the universe was once concentrated in a very hot region smaller than a sentence period. That is one part of the Big Bang Theory that it says. Letter B, the universe began billions of years ago with an enormous explosion. That is not what the Big Bang Theory says. Even though it's called the Big Bang Theory, it wasn't like, boom, bam, there's the universe. It just began in this giant explosion, everything was very small and it expanded very quickly from there. And it took time for stuff in the universe to kind of like form. So letter B is not true. Number C, the universe came into existence in an instant. Also not true. It took a long time for things to form. I guess maybe there was nothing and then like all of a sudden the universe expanded, but we're going to say that's not true. And then D, the matter and energy in the universe has taken billions of years to form. That is true. So that is also true. It took a long time for matter and stuff to form and to make planets and stuff. I guess looking at letter C, we can maybe say that this one is true as well. I guess the universe came into existence in an instant, but like all of the stuff in the universe, like stars, galaxies, planets, that took a long time to form, but the universe itself came into existence in an instant. So we can say that one is maybe true as well, I guess. Some of these ones are maybe up for interpretation. So number 8, after the Big Bang, it is theorized that the universe... So this one is... so after the Big Bang, it's theorized that the universe expanded and cooled down. So it's theorized that once the Big Bang began, the universe expanded very quickly, and over time it cooled down, which then allowed for like particles to form and matter, and then stars and planets and stuff to form over a very long period of time. Number 9, circle the letter of each sentence that gives evidence that supports the Big Bang Theory. So, excuse me. The existence of cosmic and microwave background radiation. That is something that supports the Big Bang Theory and is evidence of it. Cosmic microwave background radiation, we believe, is radiation left over from the Big Bang itself. Letter B, the redshift in the spectra of distant galaxies. That is also evidence that supports the Big Bang because it shows that the universe is expanding, which means that like a long time ago, or if we went back in time, if everything right now is expanding, then a long time ago it would have all been much closer together in a much smaller location. Letter C, the fact that the sun is about 20 billion years old. One, that's not true. The sun isn't 20 billion years old. It's only about 5 billion years old. And even if it were 20 billion years old, that wouldn't really give any evidence to support the Big Bang Theory. So, and then lastly, letter D, the pulling of atoms together into gas clouds by gravity. Also doesn't really show any support for the Big Bang. That just talks about, stars and galaxies and stuff forming, but has nothing to do with the beginning of the universe. So, not one either. All right, number 10, matter that does not give off radiation is known as. So this is known as dark matter. And it's called dark matter not because it's black, okay? It's called dark matter because we can't detect it with anything. It doesn't give off light, so it doesn't give off radiation. So light doesn't bounce off of it. It doesn't give off light. When we try to view it with like telescopes and stuff, we can't see it because if it doesn't give off light, there's nothing for us to detect and see. So we call it dark in the fact that it's unviewable, right? Not dark that it's black. Kind of like if you're in a dark room, you can't see anything, even though of course it's black, but you can't see anything either. So, and then last question, number 11, circle the letter of each sentence that is true about dark matter. Astronomers currently don't know what it is. Oh, excuse me. Astronomers currently don't know what it is or how it is distributed. That is also true. So that is true. We don't know what dark matter is. We don't know what it's made out of. We don't know where it is necessarily in space or how it's distributed. We just know that it is out there in space. And we know that because it gives off gravity. So even though it doesn't emit light, we can't see it, it does have gravity, and that gravity does affect stuff around it. So it can bend light around it, and it also contributes to the gravity in galaxies that keeps galaxies together, but we don't necessarily know where it is. So it cannot be seen directly. That is also true. We cannot see it or detect it or look at it, but again, we know that it's there because of the gravity that it gives off and the gravity that it affects on other things around it. So it can be measured using the Doppler effect. That is not true. We cannot use the Doppler effect to measure anything with it because it doesn't give off light. So, and lastly, letter D, it can be detected by observing how its gravity affects visible matter. That is true. So this is how we know that dark matter exists. It has gravity that affects visible matter. And so we can look at the gravity it gives off and how it affects things around it, and that's how we know that it is there and that it exists. So, all right, so that was the last question for the notes. Hopefully that helps. And as always, if you have any other questions on this, let me know, and I will see you in the next video.